Hallo, it's dumplet here. Here's an item on number theory. M and n are positive integers such that their GCD is 1. M cubed n to the fifth has 209 positive divisors. How many positive divisors does m to the fifth times n cubed have? Credits to the Philippine Mathematical Olympiad for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, so this question just kind of asks us about counting the divisors. So let's just try to check. M cubed n to the fifth has 209 divisors. So if you're not familiar on how to get the divisors, getting the number of divisors as well as the sum of the divisors, you guys can click this video. It's going to redirect you to a video, obviously talking about the divisors, the number of divisors, and the sum of the divisors of any positive integer. Right, moving on. I know that to get 209, the m cubed n to the fifth, I'm going to write it in prime factorization. And then you're going to take the exponents, add 1 to each of them, multiply it out, I should get 209. So let's try to take a look at the prime factorization of 209. Now, the prime factorization of 209, you guys can use the divisibility of 11 to get that it is divisible by 11. But anyways, factoring is going to give us 11 times 19. So, the 11 times 19, it suggests that it's going to be somewhat like the m cubed n to the fifth, the prime factorization of that. It's going to be something like this. So it's going to be a raised to 10, then b raised to 18, something like that. Now, obviously, there is another possibility where 209 comes from c raised to 208, a certain prime number raised to 208. Oh, by the way, a, b, c are prime numbers. I said it's going to be a prime factorization. But, well, c raised to 208 is impossible because, well, m and n are relatively prime, so they can't be the same prime number. So it's going to be probably the 11 times 19 case. So m cubed n to the fifth should look something like this. Now, I think it's rather interesting here that 10 is divisible by 5 and 18 is divisible by 3. Well, in fact, that's going to be the motivation for us to do, well, m, I could write m as a certain prime number, p raised to 6. Because, well, 3 times 6 is going to give 18. And then 5 times, well, 2 is going to give us 10. So I think I'm motivated to put n as q squared. Now, I could also try actual values of p and q. If you guys are a little bit paranoid about me using variables here. So if m equals 2 raised to 6 and n equals 3 squared, well, m cubed n to the fifth is essentially going to become 2 raised to 18 times 3 raised to 10. That's in the prime factorization. That's good. Taking the exponents, adding 1 to it, 19 and 11, and there we go. 209 it is. So, whether you're the technical type that you want to use p and q, or if you're a little bit paranoid and you want to use actual numbers, both will work. But going back to the question, let's substitute, just for demonstration purposes, I'm just going to use the 2 raised to 6 and 3 squared and check how many positive divisors does m to the fifth times n cubed have. So, 2 to the 6 is m, 3 squared is n, just directly substitute it in. Use the laws of exponents, that's going to be 2 raised to 30 times 3 raised to 6. We already have the prime factorization, that's good. Take the exponent, add 1 to it, 31 times 7, that's just simple multiplication, and that's just going to give us the final answer of 217 positive divisors for m to the fifth times n cubed. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye.